Good evening to you all.
Good evening.
Right. Is my screen is visible to you?
Yes, ma'am. Yes, ma'am.
Okay. So today we will start the session with binomial distribution. Right. Under the discrete probability distribution, first we introduced the concept random. Is my voice is not clear? MS37? Okay, thank you. So in the previous classes regarding the probability distribution, discrete distribution, first we introduced the concept of random experiment, and then we learned how we can construct a probability distribution based on the given scenario. Then we learned about the two characteristics of the discrete probability distribution, how we can calculate the expected value or mean value, and how we can calculate the variance or standard deviation for the discrete probability distribution. So today we are going to introduce a theoretical distribution, discrete probability distribution, that is called the binomial distribution, right? Here we will introduce two main discrete probability distribution. One is the binomial and one is the Poisson. These often we are using in the business scenario to calculate the probabilities, right? So in that line, first we are going to introduce the binomial distribution. Right. First, before defining what is binomial distribution, first you have to get the understanding about the binomial experiment, binomial probability experiment. Already we learned about the random experiment. So from that little bit different, for some random experiment, we can name as a binomial experiment, right? So if we want to say the particular random experiment is a binomial experiment, what are the characteristics we have to look at? The experiment can be repeated several times, right? We are able to repeat the same experiment in several times, right? But when we are doing the repetition of this experiment, that should be independent, right? So that's the performance of one experiment does not affect the performance of the second time repetition, right? So the repetitions are named as trials. Now, for example, we are tossing a coin. That is a random experiment, right? Tossing a coin is a random experiment. This experiment we can perform several times under the same condition, right? First time we are tossing a coin, then second time we are tossing a coin, and the third time we are tossing a same coin. So the first time tossing a coin is a trial, first one trial. Then second time we are same experiment, we are repeating the second time. That is another trial. So if we are repeating the three times, if we toss a coin, then there are three trials. We perform three trials. So each repetition of the experiment is called a trial. But the trials are independent, means the occurrence of the outcome of first trial does not affect the occurrence of the outcome of second trial, right? So each and every trial are independent from occurring the outcomes of the trials, right? So this means outcome of one trial will not affect the outcome of the other trial. Right? So for each trial, there are two mutually exclusive or disjoint outcomes. They are naming as success or failure, right? So specifically, each and every trial has only two mutually exclusive. That means two outcomes cannot occur at the same time, and also two are disjoint outcomes. Same example, tossing a coin. There are two outcomes, head or tail. Right? These two outcomes, head and tail, cannot occur at the same time. So they are mutually exclusive. So the tossing a coin is a binomial experiment. So binomial means there are two outcomes. That's why we put the name as a binomial experiment. Right? For another example, examining the item, whether it's a defective item or non-defective item. Right? So these are the only two outcomes, defective or non-defective. So examining the outcome or examining the product, it's a defective or non-defective, that is a binomial random experiment. Right? So here, these outcomes commonly we are naming as a success or failure. For example, tossing a coin, observing or getting the tail is the one outcome. Getting a head is another outcome. So here, one outcome, tail maybe we can name as a success, and head maybe we can name as a failure. Right? So the probability of success is fixed for each trial of the experiment. And the probability of success, that means if what is the outcome we are defining as a success, then the probability of getting that outcome is fixed for each trial. For each and every trials, the probability of success is same. Right? So our getting a tail is a half. If we are tossing a coin, by unbiased coin or fair coin, if we are tossing a fair coin, then the probability of getting head is half. And second time also, when we are tossing a coin, the probability of getting head is half. So each and every trial, the probability of success is fixed and constant. It does not change. So if these four are the characteristics of the binomial experiment, or four are the conditions of the binomial experiment. So if we want to name the particular random experiment is a binomial, then you have to check these four criteria. Right? That means there should be a fixed number of trials. Right? That is denoted by n. Then the trials are independent. The repetition of the experiments are independent. So that means the outcome of one trial will not affect the outcome of the other trial. And for each trial, there are two mutually exclusive outcomes. So for each and every trial, there are only two outcomes. These outcomes commonly we name as a success or failure. Then the probability of success is fixed for each trial of the experiment. Right. Now we are defining binomial random variable. Now first we define what is a binomial random experiment. Now we are defining a binomial random variable. Right? Here already we know the random variable. The random variable is a variable that takes values from the outcomes of the random experiment. Here also, the binomial random variable is a random variable, right, which counts the number of successes in n trials of the binomial experiment, right? So it denotes the number of successes. So how we are defining a binomial random variable? it denotes the binomial random variable is a variable that counts the number of successes in n trials of the binomial experiment. For example, number of defective items in the batch of 5 items, right? So we have a production batch. In the production batch, we are taking the 5 items, right? And for each and every item, we want to identify whether this item is defective or non-defective. So now here we are taking defective as a success and non-defective as a failure. So when we are experimenting the item or when we are testing the item, we can identify whether it's a defective item or it's a non-defective item. So each and every item when we are tested, only these two outcomes we are looking at, whether the particular item is defective or non-defective. So out of 5 items, now we are going to count how many items are defective. So the defective items may be 0, or the defective items may be 1, or 2, or 3, or 4, or 5. So we don't know what are the possible values we'll take. So now we are defining X as a number of defective items in a batch of 5 items. So here the number of trials are n, that is equal to 5. Right? Then this number of defective items, it may be the values for, if X is a number of defective items in a batch of 5 items, then X may take 0 or X may take 1 in such on, or X may take 5. Right. Similarly, then we are taking the number of correct on a 33 questions exam. Right. So there are 33 questions. We had an exam which has 33 questions. Right. Then we are classifying this question as the solution is a correct or wrong. We are classifying it as so when we are marking the exams, then we are classifying it as if the question answer is correct, then correct. If the answer is wrong, then it's wrong. So there are 2 outcomes for each and every question. You will get correct or not correct. Right? So in such manner, we are testing 33 questions. So there may be 33 correct answers, or 31 or 32 or 0 may be correct answers. So we are looking at the number of correct answers on a 33 question exam. Number of correct answers on a 33 questions exam. So this is a for example of a binomial random variable. Similarly, the number of customers who purchase out of 100 customers who enter a store. So each customer is equally likely to purchase with these assumptions, right? So we are looking at 100 customers and we are looking for out of 100 customers, how many customers are purchasing in the particular supermarket, right? So purchased or not purchased. There are 2 outcomes: purchase the product, purchase any items, or not purchased in the supermarket. So all these 3 are binomial random variables. And here you look at the binomial random variables are starting with the number of. Right? So the binomial random variable is a discrete random variable. Right? Because the values for the random variables are obtained by counting. So it is a discrete random variable. So how we are defining always the binomial random variable, when we are defining the binomial random variable, it started with the number of. Then your success, which outcome you are defining as a success, that outcome will be given here. And out of how many trials you are considering, then if there are 5 trials we are taking, then there should be 5. Now here you look at number of success. Here we are taking a defective. So number of defective items. In how many trials? 5 trials in a batch of 5 items. So similarly, number of, in this case, our success is correct answer. Then how many trials we are considering? 33. Right? Here, number of customers. Then our success, who purchase. Out of how many trials we are considering? 100. So this is the way of defining a binomial random variable. Right. Then the binomial probability distribution. How we are defining a binomial probability distribution. Already we define a discrete probability distribution in a table form. And also we looked at how we can define in a graphical form or in a list form a normal discrete probability distribution. But here we are introducing a discrete probability distribution by using a formula, right? So what is the binomial probability distribution? It's define the probability of getting X number of successes in N trials, right? So we are looking at what is the probability of getting X number of successes out of N trials. So usually the probability is defined by X equals X. X is the random variable, name of the random variable. So here the name of the random variable is number of successes. So if we know the specific situation, then we can specify number. If we are looking at the defective items, number of defective items. X will be the number of defective items. This is a general form. So here the successes, then you have to specify in a particular scenario. That is equal to nx. That is n combination of x. N combination of x. We will introduce this notation, but is then p to the power x into q to the power n minus x. So here n denotes the number of trials. X is the number of successes, right? This X, number of successes. And P is the probability of success. And Q is the probability of failure that is given by 1 minus P, right? So these are the notation. Then N combination X, that means what are the possible ways, this denotes what are the possible ways to take X successes out of N trials. What are the, how many possibilities are there to get X successes out of N trials? So that is defined by this N combination X is defined by N. This notation is now here we are reading as factorial, right? In the probability distribution, this exclamation mark is denote the factorial. N factorial divided by X factorial into N minus X factorial into P to the power X into Q to the power N minus X. So here X is the number of successes in N trials. So because we are considering N trials, then X may be 0 or X may take 1 or X may take 2 up to X may take N. So N is the number of trials. X, this denotes the number of successes, right? Now for example, we are taking tossing a coin 2 times, right? Binomial X is now we are defining X random variable as number of tails when tossing 2 times. or number of trials in tails, number of tails in 2 tosses. Right, number of tails in 2 tosses. Right. So here n. How many trials here we considered? N is equal to how much in this random variable? Anyone unmute your mic and say, what is n? Value for n? Anyone? N is equal to? N is the number of trials. How many times here we are tossing a coin?
2 times.
2 times. So what is n? N is equal to 2. Then what are the possible value for x? Possible values for x? X is the number of tails. So what are the possible values for x? If you are out of 2 times, if there is a no tails, then what is x will take? Students, you have to interact. Otherwise, there is no use of teaching you. So, when we are tossing a 2 times when we are tossing a coin, if there is no tails, then what is the value for x?
0.
0. If we are tossing, when we are tossing a coin 2 times, if we are getting only 1 tail, what is the value for x?
1.
1. If we are getting 2 tails, then what is the value for x?
2.
Right? So now in similar pattern, here also we define, right? N is our number of trials, how many times we are repeating our experiment, and x is the number of successes. So here x is the number of successes is tails. The success we are getting as a tails. And the trials n is here 2. So when n is equal to 2, the possible values for x is 0, 1 or 2. Now suppose now here we are taking n is a 4. 4 tosses. The number of tails in 4 tosses. So now what is n? In this case, what is n? 4. What are the values for x?
0, 1, 2, 3, 4.
0, 1, 2, 3, 4. Similarly, whatever and binomial experiment when we are defining, you have to find out what is x. You will be able to define what is x, what is n, what are the values for x. These 3 things you will be able to identify. In addition to, you will be able to identify what is p. Right? So if we know the n, x, p, then only you can calculate the probability. Right? So this probability is here. What is this probability calculates? The probability of getting x successes. Right? So in this case, if we are calculating p x is equal to 2 for this example, what does this mean? Probability of x is equal to, what does it mean in this case, in this particular example? Probability of getting 2 tails, right? Now, because here we are defining number of tails. So, probability of x equals 2 indicates the probability of getting 2 tails. If we are defining x in such manner, then probability of x equals 2 is the probability of getting 2 tails. Right. If probability of x equals 0, what does mean in this particular example? Anyone? What is the meaning of this probability?
Probabilities get tails is 0.
Probability of getting no tails, right? Probability of getting no tails or 0 tails, right? So this is the explanation of this probability. Now we come to the this n combination x. Right now here simple example we take n is a 2. Again we are having it a 2, right? In the 2 tails, now we want to look at 1 tail, right? We want to look at out of 2 tosses, we want to get 1 tail. So this notation tell how many times we can get 1 tail out of 2 tosses. Anyone, can you tell how many times we can get 1 tail out of 2 tosses? When we are tossing a coin, what is the possibility of getting 1 tail? What are the possibilities to get 1 tail? You will get h comma h, right, in 2 tosses, or ht or th or t comma t. This is one possibility. This is one possibility, right? But here we are looking at without order. This is actually 2 factorial divided by, according to this formula, 1 factorial into 2 minus 1 factorial, right? So that is equal to 2 factorial divided by 1 factorial into 2 minus 1 factorial, right? So here actually how many possibilities here getting 1 tail? This is one of the possibilities. This is one of the possibilities. So when we are tossing a coin 2 times, there are 2 possibilities to get 1 tail. Am I right? Yes or no? When you are tossing a coin 2 times, this is one possibility, right? In the first time you get head and the second time you get tail. Or the first time you can get tail and the second time you can get head. So how many possibilities are there to get 1 tail?
2.
2 possibilities, right? So now this is also, we are calculating how many possibilities to get 1 tail in 2 tosses. So this 2 factorial means we are multiplying numbers from 1 to 2. We are multiplying numbers 1 to 2. So 2 factorial means 1 into 2, that is 2. So 1 factorial means 1 into 1, that is 1. This is 2 into 1, right? 2 into 1, it is 1 into 1. So that is 1 factorial, right? From 1 to, what is the factorial we are considering? Up to that, all the numbers should be multiplied. So that is 1 factorial is always 1. Don't need this one. 1 factorial is always 1. That is 2 divided into 1 into 1. So that is 2. This tells n combination x. In some books, they are writing it as a nx. In some textbooks, you can find it n combination x. N combination x. This indicates out of n trials, how many possibilities to get x successes? How many possibilities to get x successes. That is defined by this formula, right? Now I'm going to erase these other things. Right. Now, so n factorial means, right? What is the meaning of n factorial? You have to multiply all the numbers, all the positive numbers from 1 to n. So 1, 2, 3, 4 up to n. Right? So 3 factorial means 1, 2, 3, that is 6. Then 4 factorial means 1, 2, 3 into 4, right? That is 24. Similarly, you can calculate the factorials. Similarly, 1 factorial is always 1, and also 0 factorial is also equal to 1. This you have to know that, right? 1 factorial is 1, 0 factorial is also equal to 1. And other things you can calculate this one. But for the binomial probability distributions, when you are calculating the binomial probability distribution using the calculators, for the exams, you have to use the calculators, right? We will not provide the tables, right? So you have to use the calculator. Based on the calculator, you have to calculate the binomial probability. So all you have to practice in your calculator, there is a direct calculation you can get, NCR. You check with your calculator, there is a notation NCR. Using this function, you can calculate this combination, right? You don't need to calculate separately 3 factorial, 4 factorial. In straight away, you can calculate, use this function, then you can get the value for NCR. For example, if you want to calculate 5, 2, 5C, this is in the calculator form. This notation you have to find out. 5C2, C is a combination, right? So out of 5, but how many possibilities? We get 2. How many times? We get 2 successes out of 5 trials. So there you have to give the numbers 5, then that function, then 2. So by manually when we are calculating, it is equal to 5 factorial. Then x is 2, that is 2 factorial into n minus x, 5 minus 2, 3 factorial. So when we are simplifying, this 5 factorial means 1, 2, 3, 4 into 5 divided by 2 factorial, 1 into 2 into 3 factorial, 1 into 2 into 3. So when you are looking at 3, you also do 3 and 2, that is 10. If you check in your calculator, then you can get the value 10, right? So if you are not familiar how we can use calculator to evaluate this combination values, from the website you can get the idea, right? Then you have to use your calculator to learn how we can find out this combination value. Right. Then the parameters. What are the parameters of a binomial? Because when we are taking the binomial formula, that is defined by Px is equal to x, nx, p to the power x, q to the power n minus x, where x, the possible values for x is equal to 0, 1, 2, up to n. So, if you want to calculate the binomial, we have to know the value n and we have to know the value p. If we know these two values, then only we can apply this formula to calculate the probability for the particular number of successes. This x, small x denotes the number of successes. This capital X, the name of our random variable. Right? So these N and P are deciding the binomial distribution. That's why we call these N and P are the parameters of the binomial distribution. So how many parameters we have for the binomial distribution? Two parameters, where N and P. N is the number of trials and P is the probability of success. When we are looking at the probability distribution, shape of the probability distribution, it may be symmetric or skewed. Symmetrical means bell-shaped curve. This binomial distribution, probability distribution curve may be symmetric or skewed. For example, you can get your probability distribution curve in such manner. This is a bell shape, or you can get in such manner, right? Skewed or symmetric. So when you will have a symmetrical shape, when P is equal to 5, when probability of success equals 5, the binomial distribution will be symmetric. But this not depend on the value of the number of trials, right? The shape of the distribution, the shape of the binomial distribution is decided by the probability of success. The shape of the binomial distribution is decided by the probability of success. If P is equal to 0.5, then the distribution will be symmetric. If P not equal to 0.5, the distribution will be skewed. So this is the examples for this one. And also here also we are taking the mean value for a binomial distribution. How we are calculating the mean value? By using N and P. Competitive product, right? So here we are looking at so we taking 5 consumers, right? And we are asking each and every consumer whether you are preferring our product over the competitor's product. So there are 2 products. One is our product and another one is the competitor's products. So whether you are preferring our product or competitor's product. So the answer will be yes or no. If we are preferring our product, yes. If we are not preferring our product, then no. Right? So there are 2 outcomes. So similarly, 5 consumers we are taking and we are asking them whether you are preferring our or competitors. Then what is the probability that exactly 2 of them prefer your product? Right. Now, we have to calculate the probabilities. Right now, they are asking the probability that exactly 2 of them prefer your product. Right. So now we look at. First, you have to identify the things. What are the things here given? The probability of preferring product. Right. So first we will note that one. Probability of preferring is what is the probability of preferring product? Unmute your mic. What is the probability of preferring the product? Preferring our product or your product. Now tell the answer. What is the probability of preferring your product? There are 193 students, right? You can answer. What is the probability of preferring your product? Look at the first one.
0.25.
0.25, right? You have to answer quickly. 0.25. How many times we are repeating the experiment? How many consumers we are testing or asking?
5 consumers.
So n is equal to 5. Right? Now we have to define our random variable. So here now we know the probability of preferring product and 5 times we are testing. Right? So now we want to look at the probability that exactly 2 of them prefer your product. So now we are taking a random variable x. How this variable can define? X is the number of consumers, right? Number of consumers preferring your product. Number of consumers preferring your product out of how many consumers all together we consider? Out of how many consumers? Out of 5 consumers. In such manner, you also have to define, right? X is the number of consumers preferring your product out of 5 consumers. Out of 5, how many consumers are preferring your product? So now, so this is the probability of preferring your product. So here it is actually, there are 2 possible outcomes in this test. What are the 2 possible outcomes? In testing this product, there are 2 possible outcomes. What are the 2 possible outcomes? Preferring the product, not preferring the product, right? So here 2 outcomes. Preferring the product, when we are testing or when we are asking the consumer will answer prefer the product, or the consumer can answer not prefer the product, not preferring the product. So here we are looking at the probabilities related to prefer. We are looking at the probabilities related to prefer. So we are taking this as a success. So success is preferring the product, and this is the failure, right? So what is P? In this case, what is P? How much P? What is the probability of preferring the product? Here we look at probability of preferring your product is 0.25. And n is equal to 5. So this x has a binomial distribution. Now we know that there is a fixed number of trials, n number of trials. These trials are independent, and the probability, there are 2 possible outcomes in this scenario, that is preferring the product and not preferring the product. And the probability of success is fixed in each and every trial out of 5 cases. So it has a binomial distribution, right? So now I'm going to erase this one and write continue this one. Right. So now we have X. From this given scenario, we know that X has a binomial. If we denote this notation, X follows binomial distribution with what are the parameters you have to specify. With n is equal to 5, the number of trials with n is equal to 5 and p is equal to 0.25. So from this, we know that probability of X, if X has a binomial distribution, then probability of X is equal to nx p to the power x q to the power n minus x, where n is equal to 5, x, the specific value, p is equal to 0.25 in this case, and q is equal to 1 minus p, that is 0.75 into n, here 5 minus x. Then you have to specify the possible values. X may be take 0, 1, 2, 3, 4, 5. In such manner, you also have to write, when we are asking the probability distribution for this particular scenario, in such manner you have to write it. Right. Now, in this case, now we are coming for the question, right? What is the probability that exactly 2 of them prefer your product? So how now this will come? What is the value for small x in this case? Anyone answer it? Otherwise, I am going to stop the lectures. What is the value for this small x? So Px is equal to 2, right? That is 5 to 0.252 into 0.75, 5 minus 2. Right? Use your calculator and get the value. All these things you can get from the calculator, and you can get the value for this, right? This is the answer. Then you have to simplify using your calculator, right? Right. Then mean and standard deviation of a binomial random variable, right? So similarly, for any probability distribution, we can get the mean. Here, this case, expected value. This is expected value. Right? So the expected value and standard deviation. So for a binomial experiment, there are if n independent trials and the probability of P has a mean success is P, then the expected value is defined by NP and the variance or standard deviation is NP into 1 minus P. In this example, there is a brand soda and the generic soda. There are 2 kinds of types of soda they are taking. One is a generic soda, and other soda is with a specific brand name. Right? And the brand name. So there are 25% of the tasters they can distinguish between the two soda. Then they are taking only 10 tasters and asked to take taste test and guess which cup contains a brand name soda, right? There are 2 cups and then they are asking which cup contains brand name soda. These tests are done independently in separate location so that the tasters do not interact with each other during the test. The count of correct guesses in 10 taste test has a binomial distribution, right? So they are taking the number of count correct guesses in 10 taste test has a binomial distribution. So what is the success outcome? So based on this one, your success outcome is defined by correct guess right? Failure outcome incorrect guess identifying the brand soda, right? Then we are defining, take the random variable x. According to this one, the number of correct guesses in 10 taste test, right? This is answer for first question. And second question, this is our random variable. And second one, what are n and p? So for the second one, according to this example, n is equal to 10 and p is equal to 0.5. Then what is the probability of exactly 5 guesses? So probability of x equals 5. So that is equal to, because x has a binomial distribution, so x is equal to x, nx, p to the power x, q to the power n minus x. From this one, your n is 10, x, p is 0.25x, and q is equal to 0.75 n minus x, 10 minus x. The possible values x equals 0, 1, 2, 10. So the third question, they are asking to calculate exactly 5, right? Exactly 5. So that means probability of x is equal to 5. So that is 10 small x 5. Then 0.25, x is equal to 5, into 0.75, 10 minus 5, 5, right? Using the calculator, you calculate the probability value. Take a 1 minute time, and if you want, you can note it, and I'm going to raise this one. Right. Then for the fourth question, they are asking at least 2 correct guesses, right? There's a combination of events here, at least 2 correct guesses. So probability of x, at least minimum 2. There may be 2 or more than 2. At least means minimum 2. So probability of x greater than or equal to 2. Right? So here we know the values, there are up to 5 correct guesses. So this probability is equal to Px is equal to 2 plus Px is equal to 3 plus Px is equal to 4. Plus Px is equal to 5. These 4 probabilities you have to calculate, right? So here this is equal to actually 5, 2 and 0.252 into 0.753 plus 53 0.253 into 0.755 minus 2 plus x is equal to 4, 5, 4, 0.254 into 0.751 plus 5, 0.255 to 0.750. Right? So these 4 probabilities you have to calculate. So there is a table also there. By using the table you can calculate, but for the exams, the final exam is a physical exam. So during the final exam, you cannot use the tables. Right? Only the calculator will be provided. Using the calculator, you have to calculate the probability. So from today onwards, you have to practice by using the calculators. Right? This is method 1. Right? Not this. Going to raise to write the method 2. Then method 2 for the same question, right? What is the probability? At least 2 correct. So probability of x greater than or equal to 2. That is equal to actually 1 minus probability of x less than or equal to 1. Because we know that the total probability is 1. For any probability distribution, the total probability is 1. So because here x takes the value, in this case, the values for x are 0, 1, 2, 3, 4, 5. We have to calculate the probability for these 4 values. That is x greater than or equal to 2. So when you are adding probability of x equal to 0 plus x equal to 1 plus x equal to 2 plus x equals 3 plus x equals 4 plus x equals 5, that will be 1. So from the 1, if we deduct these 2 probabilities, then you will get the probability for this one. So this is inverse method. So probability of x greater than or equal to 2 also equal to 1 minus probability of x less than or equal to 1. This is equal to 1 minus p x less than or equal to 1 means it may take 0 or it may take 1. So x equals 0 plus probability of x equals 1. Here only the 2 probabilities you have to calculate. So this is equal to 1 minus 5, 0. P is equal to 0.250 into 0.755, right? Plus 5, 1, 0.251 into 0.75, right? By simplifying this case, then you can get the probability, right? And check whether in both methods you get the same answer. Right? It take 1 minute and I'm going to raise this one to do the 5th question. Right. Okay. 5th question. What is the probability of at most? These wordings are important, right? Then only you can write the possibility. At most 3 correct guesses. So here at most means maximum 3. You can't exceed more than 3, right? Maximum 3. So probability of x less than or equal to 3. Probability of x less than or equal to 3. So that is equal to probability of x equal to 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3, right? From this part 4, right? From the part 4, you can get the answers for these things, right? You can calculate in such manner, or probability of x less than or equal to 3 equals 1 minus probability of x greater than or equal to 4. This is also equal. That is equal to 1 minus p x equals 4 plus p x equals 5. Because there are only 5 trials, so these 2 probabilities will be, right? Both are same. In either one of the way you can calculate. For more, by whichever method you follow, for some probabilities you can get the answers from the part 4. Right? Then this is for question 5. Then for question 6. What are the expected value and the standard deviation? So expected value for the x, for the given random variable, Usually we are denoting EX. But in the binomial case, that is N into P. So here N is equal to 5 and P is equal to 0.25. That is 1.25. Right? So this means on average, 1.25 customers identify the particular brand as correct, right? Identifying the correct brand, right? Identifying the brand. That is, this means in the long run, on average, 1.25 customers guesses are correct. 1.25 customers guesses are correct. Then standard deviation, that is denoted by sigma. That is square root of NPQ. So that is equal to square root of 5 into P 0.25 into Q 0.75. 1 minus P, that is 0.75. Then you get the answer using the calculators. So this is the method of calculating the binomial distribution. Take 1 minute and I am going to move for the next slide. This is the exercise because if you are interacting with me, then I can give some explanation on it, but you are not interacting. So you have to get the understanding on it, what is going on. So you learn yourself. If you have any doubt, then if you are asking in the next class, then I will explain. Otherwise, it's not, right? This is also exercise. Now we are coming to the next theoretical distribution, that is the Poisson distribution. Here also, it is also discrete probability distribution. Similar to binomial, but the counting number of events is little different than the binomial distribution, right? Here also, the number of events that occur in an interval, right? But in the binomial, we are counting the number of successes occurred in the number of trials we perform. Number of successes occurred in the number of trials we perform. But here, we are also counting the number of events, like number of successes, but we are counting in an interval. That means we are counting the events per unit. This per unit may be time duration or length or area or space. But both are counting the number of successes. But in the Poisson distribution, these successes we are denoting, we are naming as events. And the trials here we are looking at in the interval format. This interval format is a per unit. It may be time or length, area or space. Example, number of customers. Same thing, right? Number of customers arriving in 20 minutes. So here our time length is interval time we are considering. In a 20 minutes time, we are observing how many customers arriving. Number of strikes per year in the US. So here our interval, here space, area, time and area here denote per year in the US. Number of strikes per year in the US. Then here also number of defects per lot of DVDs. Number of defects. We are not taking only 5 or 10. DVDs. Here we are taking a group of DVDs, and in the group of DVDs, it may be 1,000 or 10,000 DVDs. Then we are looking at the number of defects. So similarly, for the how we can identify a given random variable is a Poisson random variable, like the binomial. Also, there are some characteristics are there. First one, it consists, the variable describes counting number of times an event occurs during a given unit of time or in a given area or volume. But in the binomial, how we are counting, we also counting the number of successes in the trials, in 5 trials or in 10 trials. But instead of trials, in the Poisson random variable, we are counting events during in a given unit of time or in a given area or volume. Right? Then the probability that an event occurs in a given unit of time, area or volume is same for all units. In the binomial, the probability of success is same in all trials, but here also the probability that an event occurs in a given unit of time, area or volume is, we are taking a 1 hour time, then another 1 hour time, then another 1 hour time. In 3 1 hour times intervals, the probability of occurring particular event is same, right? Then the number of events that occur in 1 unit of time, area or volume is independent. How the trials are independent, here also this number of events that occur in 1 unit of time, area or volume is independent of the number that occur in any other mutually exclusive unit. That is also mutual, that does not depend, right? Then here the mean number of events in each unit. Right? The mean number of events in each unit is denoted by lambda. So in the binomial, we are looking at the number of trials and the probability of success. But in the Poisson, here we are looking at the average number of events occurred in the particular interval or area or space or volume in such time, in such manner, we are looking at the average number of events occurred, right? The mean number of events. So this, they also be looking at the 4 characteristics to define a random variable. Here also 4 characteristics we are having to define a Poisson random variable. So you will be able to distinguish how we can distinguish the Poisson random variable and the binomial random variable. This type of question we will ask, right? Distinguish between the Poisson random variable and the binomial random variable. Then by specifying these characteristics, you have to distinguish. Right. Similarly, in the Poisson probability distribution, right? How we are defining the binomial, here also we are defining specific formula we are having. Probability of x. This is actually same as x is equal to x. That is probability of x. That is lambda to the power x, e to the power minus lambda divided by x factorial. The same thing, x factorial. Lambda is the average number, right? Mean or expected number of events. Here, expected number of events in 1 unit. Expected number of events in a unit, in 1 unit. This X count the number of events occurred in a interval or in a space or in an area. But because the area, we cannot define the maximum number of events. So here the maximum is not defined. But in the binomial, we can define the maximum number. If there are 5 trials, then X will be 0, 1, 2, 3, 4, 5. If there are 8 trials, then X will be 0, 1, 2, 3, 4, 5, 6, 7, 8. But for the Poisson, the maximum number of events we are not able to define. So the maximum number here we not specify here. Right? Expected number is mu. Sorry. Lambda is average number of units, right? Then E is an exponential number, that is 2.718, and X number of events per unit, right? And like expected value, Ex is equal to mu, that is equal to lambda, and variance of X like a binomial, sigma square, that is also lambda, right? Both cases. For the Poisson, expected value and variance both are defined by lambda. Lambda is the average number of events in the unit of interval or time or area or volume or space, right? And probability is defined by this form. So, like in the binomial, the parameters are n and p. N is the number of trials, p is the probability of success. But here the parameter is lambda. Only if the average numbers are known, then we can calculate the probability, right? Because we know that p x e to the power minus lambda, lambda to the power x over x factorial, where the possible values for x 0, 1, 2, 3, and so on, right? So here, if we know lambda, then all the probabilities you can calculate. For this also, e to the power minus lambda, you can calculate that this has this function, right? This function also there, lambda to the power x also you can get from the calculator. Then you can calculate the values. Right? Then looking at the Poisson shape, it is a right skewed, right? When the mean, the expected value lambda is small. When lambda is small, you will get the skewed. But when lambda gets large, then it is also approach symmetrical with a peak in the center, right? Here also right skewed. But for the binomial, right skewed and the left skewed are possible. For when p is equal to 0.5, it is a symmetrical. But here the lambda, when lambda is small, the Poisson will be right skewed. And when lambda gets large, you will get the approximately symmetrical. Then mean of the Poisson distribution, lambda already we looked at, and the variance is lambda. So standard deviation, square root of lambda. And this is the shape. Now we are coming for the first example. A car passes along a particular road at random with average 3 cars per minute. Right? So only we know the average number per minute time in a particular road, along a particular road. Right? How many cars are passing? Then find the probability that in 1 minute, right? In 1 minute, how many cars? Exactly 3 cars pass. So here the binomial is not appropriate, because if we want to apply the binomial, then we have to know the number of trials and the probability of success we have to know. But here only we know the average number of cars passing a particular road. So here only the Poisson distribution we can apply. So now, according to this scenario, we are defining X equals, here we have to calculate these probabilities in 1 minute time, right? We can calculate this probability in 1 minute time. So X denotes the number of cars passing along a particular road in 1 minute. Right? In the binomial, we are specifying in 5 trials or in 10 trials. Similarly, here also the interval or space, anything you have to define, right? When you are defining your random variable, X equals number of cars passing along a particular road. From this example, we get in 1 minute time. This is very important, right? So then X, according to the given scenario, X has a Poisson distribution. Here you have to specify the parameter. What is the parameter? Poisson distribution with lambda equals 3, where lambda, average number of cars passing per minute. Lambda is equal to, where lambda denotes average or mean number of cars. Average number of passing in 1 minute. Passing along road, right? Passing along a particular road in 1 minute. So in all the things, this unit should be same in 1 minute time. Only we are looking at for 1 minute time, right? So this should be same in X and in defining the lambda. In both, this interval should be same, right? So then X has a Poisson distribution. So according to the Poisson distribution, P X equals X e to the power minus lambda, lambda to the power X over X factorial. So here we know the lambda 3. So e to the power minus 3, 3 to the power X over X factorial. Here you have to specify the values for X, that is equal to 0, or it may be 1, or it may be 1. There is no cars passing in 1 minute time, or there is a 1 car which passes in 1 minute time, or 2 cars, or 3 cars. But we don't know the maximum, so the maximum value can be specified. Right? Take a 1 minute and note it. Then I'm going to raise these other things. Right. Then part A, exactly in 1 minute time, exactly 3. So how we can write in the notation for probability of x equals 3. So that is equal to e to the power minus lambda, lambda is 3, and 3 to the power x, small x here 3 over 3 factorial, right? This one you can get the calculator, this one you can get calculate, this also you can get in the calculator, right? Then you can simplify and write the value. Right? Then for part 2, fewer than 3. So it less than, fewer means less than 3, fewer than 3. So according to this wording, now we have to calculate the probability of x less than 3, right? So it is equal to, it may be 0, or probability of x equals 1, probability of x equals 2. Less than 3, fewer than 3 means less than 3. So there is no 3. So 0, 1, 2, because why? Your x values are taking 0, 1, 2, 3, and so on. So fewer 3 means only 0, 1, 2. Then this is equal to e to the power minus lambda e to the power minus 3, lambda e to the power minus lambda, lambda to the power x, here x is equal to 0 over 0 factorial, plus e to the power minus 3 to 3 to the power 1 over 1 factorial, plus e to the power minus 3, 3 to the power 2 over 2 factorial. And also don't forget, 0 factorial is always 1, and 1 factorial also always 1. These are the things. Calculate this one. Then by using your calculator, you can get the value. Right? Part 3. No cars pass. Right? In 1 minute time, no cars pass. So that is probability of x equals 0. Probability of x equals 0. There is, because x denotes the number of cars passing along a road in a 1 minute time. So if no cars pass, then this value will be 0. So that is e to the power minus 3, 3 to the power 0 over 0 factorial. So what is the probability here you got? That will come here. Right? Not this one. I'm going to erase it. Right. In fourth part, at least 2 cars pass. So probability of minimum 2 or more than 2. Minimum 2. So probability of x greater than or equal to 2. Minimum 2. So here that is equal to probability of x equals 2 plus probability of x equals 3 plus dot, dot, dot. Because we are not able to specify the maximum value. We don't know the maximum value. So for this kind of probability, if we are taking in such manner, we can't calculate for the Poisson, right? For the binomial, you can calculate because we know the maximum. But here, we don't know the maximum. So how we can calculate? This is equal to, we have to take the complement of this event. So probability of x greater than or equal to 2, we can write as 1 minus probability of x less than or equal to 1. Right? So that is equal to 1 minus probability of x equals 0 plus probability of x equals 1. That is equal to 1 minus e to the power minus lambda minus 3, 3 to the power 0 over 0 factorial plus e to the power minus 3, 3 to the power 1 over 1 factorial. By simplifying this one, we can get the probability. Not this one. For the part B, after raising this one, then I am writing for part B. Right. Now part B, find the probability that in 2 minutes. Now here you look at in 2 minutes. But here in the part A, 1 minute. Part A, 1 minute. And also we know the average 3 per minute. In 1 minute, we know the average. But here, now we have to calculate the probabilities for 2 minutes. So now first thing, now we define our random variable. Right. So for part B, we are taking X, number of cars, passing along the road, on a particular road in 2 minutes time. In 2 minutes. Give me a 1 minute time. Huh? Right. Now here, we have to take X number of cars passing along road in 2 minutes, because here the probability calculation is in 2 minutes. But lambda is in 1 minute. So what is that? Here in this case, lambda is equal to for 1 minute 3 cars average, then 3 into 2 for the 2 minutes, that is 6. Right? So now we have to calculate the probability exactly 5 in 2 minutes time. So probability of X equals 5, that is e to the power minus lambda. Here now lambda is 6. Minus 6. 6 to the power 5 divided by 5 factorial. So when we are defining or calculating the probabilities, the average number and what is your random variable tally with the time interval, right? Here, if here is a 2 minutes time, then lambda also for the 2 minutes, right? If we are taking 5 minutes time, then lambda should be 5 minutes time, calculated in that 5 minutes time. So in the Poisson, only you have to know the average number, but that average number that should be corresponding to the random variable defined in the particular interval, right? Then now here look at mean and the standard deviation of cars passing in the 4 minutes time. So now your time interval is 4 minutes, right? So the lambda also should be in 4 minutes. So now for the part C, your lambda is equal to 3 into 4. For a 1 minute, 3 per minute. So lambda is equal to 3 into 4, 12. So according to that one, for the Poisson distribution, expected value, right, X, that is equal to lambda, that is equal to 12. And the variance also is equal to lambda, that is 12. So now here you have to get the standard deviation. Square root of variance of X that is equal to square root of 2, right? So for the Poisson distribution, the thing you have to remember the time interval. What is the time interval or what is the space we are taking, right? That is, you have to remember that one when we are calculating the Poisson probability distribution, right? So the next slide. Here exercises. So you read carefully how the previous one we did, the similar pattern you have to do. If you have any doubt, you can ask me, but I'm not asking. If you are bringing your doubts, and then you can ask, then I clarify during the class. Otherwise, I will not bother about it. Right. So anything you want to clarify from me today, from today class? Right. So the next class will be the continuous probability distribution. Friday morning, 7. Are you okay with 7 o'clock morning, 7? Class rep? Because 7 to 9, there is no any power cut issues. right? So Friday morning, 7 o'clock, we will meet.